Number 17. Yes, good morning to all of you, my dear children. In this exercise, in this chapter, continuity and differentiability, in the exercise 5.21, 16 questions were completed so far. Okay. Are there any doubts in this question number 16, from question number 1 to 16? Are there any doubts in these questions, 16 questions? Have you?
No,
any
sir.
Doubts? Do you have any doubts? Yes. Now come to the question number 17. Now come to the question number 17. Day by day, every day, you have to clear your doubts one by one. Not all of a sudden, all the doubts. Don't try at last moment. Don't try to clear your doubts at last moment. In the 11th hour, don't try to clear your doubts at the 11th hour. 11th hour means in the last moment, in the last month of an academic year. Don't try to learn in 1 month only. This is a learning process. You cannot learn. You cannot get the knowledge of the subject within 1 month. If you get the knowledge of any subject within 1 month, why do they give 1 year for learning this subject? Don't think like that. We can learn these doubts. We can clear our doubts at the last moment. Why to ask these doubts now? Don't think like this. If you have these type of thoughts in your mind, erase it, that type of thoughts from your mind. Day by day, can you construct any building within 1 day or within overnight? In overnight, can you build any project or any building?
No, sir.
Nobody can construct a building within 1 day, within overnight. No one can build. Similarly, in the same way, you cannot get the knowledge overnight. Within a overnight or within 1 month or within 1 day, you cannot get the knowledge. You cannot clear your doubts in 1 day or in 1 month. You cannot clear your doubts. Right from the beginning, at least right from the beginning, your PA1 marks, your PA2 marks, and the term 1 exam marks, all these marks will be considered. They will be considered for assessing your capacity. Please remember this point, my children. Please remember this point. Every exam is important and every 1 mark is very, very important. So right from the beginning, I'm telling you again and again, right from the beginning, try to clear your doubts day by day. Suppose you have doubts today, 1 doubt, get it be cleared on the same day. If you have 2 doubts, get it be cleared on the same day. Okay, my children, this is a learning process. Please remember these points. That is why I'm asking you every day, do you have any doubts? Is it clear? Immediately on the same day, you have to practice that sums without copying. On the same day, you have to practice the sums. On the same day, you have to spend. As you are going to write board exams, you have to practice on the same day itself. What, my dear Kevin Paul? Any doubt? What, my dear Kevin Paul? Do you want to say something? Kevin Paul?
No, sir.
Yes. Now come to the question number 17. And moreover, don't expect every question should be explained in the classroom. Because of time factor, previously also I told many times, because of time factor, I cannot explain each and every question in the textbook. I will explain concepts, I will explain some questions in the exercise. The remaining part is in your hand. You have to practice, you have to try the sums which were not explained in the classroom. Okay. So you have not given that question as homework. Don't say these silly matters. And that today you have not given this question, sir, as homework. You are not small kids. You are not small kids, and no need to give separately. This question is homework. This question is classwork. Like this, we cannot separate the sums in the exercise. I cannot separate the sums as classwork sums. These are homework sums. Whichever sums were not explained in the classroom, you have to practice them by yourself, by seeing the classwork notes, by watching the videos and providing you the videos of every class. I'm providing you the videos of every class right from the beginning. Very few classes, less than 10 classes, I think, less than 10 classes right from the beginning may not be posted. I think most of the classes I posted the classes in the video format as well as in the PDF format also. I provided both, okay, both the forms, video format as well as in the PDF format. In two formats I provided. It is in your hand. Please remember this point, my children. You are going to write board exams. Keep this point in your mind. Be serious in your studies. Don't be lazy. Okay. If any doubts are there, get your doubts clarified on the same day or at least next day. At least next day. Don't postpone. Don't postpone the time to clear doubts, your doubts. Okay. Now come to the question number 7. Find the relationship between A and B so that the function f defined by f of x is equal to, given f of x is equal to ax plus 1, when x is less than or equal to 3, and f of x is equal to dx plus d if x is greater than 3, is a continuous function. This function is continuous. At x is equal to 3. At x is equal to 3, it is given that the given function is continuous. It is already given. No need to check, no need to verify whether this function is a continuous function or not. Already it is given. It means this function satisfies the condition of continuity of f. Condition of continuity of f. When do you say a function is continuous at x is equal to a? How do you say a function is continuous? Suppose given function is f, given point is a. When do you say, how do you say f of x is continuous? F of x is continuous at x is equal to a. What is the condition?
Sir, x tends to a minus limit of f of x should be equal to x tends to a plus limit of f of x.
Yes.
Yes, is equal to f of a. Sir.
Yes. Left hand limit and right hand limit of f of x at x is equal to a, and it should be equal to f of a. If these three values are equal, then it is said to be continuous function. It is already given that it is a continuous function. If it is a continuous function, what is the relationship between A and B? Okay, so at which point the function is divided in two ways? At which point?
3, sir.
At 3. See, at previous also I told you, highlighted by circle. In previous examples also, I highlighted to know the points at which the function is defined in different ways, left side and right side of that particular point. So at this particular point, 0, 1, 2, 3, 4, 5. Here minus 1, minus 2. At this particular point, at x is equal to 3, f of x defined left side and right side. What is f of x? Tell me, left side. What is f of x? Say
Ax
fast.
plus 1, sir.
Yes. X plus 1. Less than or equal to. See here. If you have observation skills, if you have most observation skills, from the given data itself, you can get the idea. From the given data itself, if you observe carefully, the given data gives, it will help you in solving the problem. So, what is f of x? If x is greater than 3, if x is greater than 3, what is f of
bx
x?
plus 3, sir.
Bx plus 3. At exactly 3, what is f of x? At exactly, what is f of x?
Ax plus 1, sir.
Ax plus 1. Ax plus 1. At exactly f of c, x is equal to 3. Previous also I told you. I stressed at that point also. At x is equal to 3 means less than or equal to. I stressed at that point clearly. Please remember and understand this point. So let us find LHL, RHL. So let us find LHL. What stands for LHL? Left hand limit. Remember this point. LHL stands for left hand limit of f at x is equal to 3. So as x tends to 3 minus limit f of x, that is equal to as x tends to 3. What is f of x here? If x is less than 3, 3 minus means not minus 3. Don't be confused. As x tends to 3 minus means less than 3. Don't confuse it with minus 3. It is not minus 3. 3 minus means less than 3. 3 superscript minus symbol. 3 superscript minus symbol means less than 3. Not minus 3. Don't be confused with minus 3 means before number. Before this number. That is a sign of that number. But this does not denote sign of this number. It is denoting left side numbers very near to the number 3. Very near to number means less than 3. So what is f of x here? Ax plus 1. Because x is less than 3. Then what is the limit of this function? A into 3 plus 1. That is 3a plus 1. By substitution method. Similarly, we find 3 plus as x tends to 3 plus limit f of x is equal to as x tends to 3 limit. What is f of x here? Bx plus 3. Because x is greater than 3. 3 plus means greater than 3. So b into 3 plus 3. That is equal to 3b plus 3. By substitution method only. Most of the cases use the substitution method to find limit of the function. Now what is f of 3 in this function? Substitute 3. F of 3. A into 3 plus 1. That is 3a plus 1. So let us mention this is 1 and this is 2 and this is 3. As the given function is continuous function, as f of x is continuous at x is equal to 3, these 3 results should be equal. Yes or no? These 3 results should be equal. So we equate these 3 results. We equate these. Okay, my children. Now take the screenshot of this page number 1. We continue this. We find the relationship between A and B. We find the relationship between A and B. In the meantime, take the screenshot. Take the screenshot of this page number 1. Make it fast. Okay, have you taken the screenshot?
Yes, sir. Taken, sir.
Yes. Previously also I told you many times, it is a safe side point of view. I am telling you. Next, if any technical problem arises, I cannot post the classwork notes in the form of PDF. That is why I am asking you every time to take screenshot. Later, don't ask me, sir, you have not posted the classwork notes on that day, sir. That is why I could not write the classwork notes. Don't say lies. Don't say lies to escape from your duty. On that day, you have not posted the classwork notes, sir. It's your duty to prepare the classwork notes by yourself only. Okay. Now, as f of x is continuous, f of x are given. F of x is continuous at x is equal to 3. By implies, if it is a continuous function, all these three values should be equal. That implies x tends to 3 minus limit f of x is equal to, and x tends to 3 plus limit f of x is equal to f of 3. This implies we have already found left hand limit, that is 3a plus 1. 3a plus 1. This is 3b plus 3. That is equal to 3a plus 1. So we have equated all these three values because it is a continuous function. Now, by taking these two parts, in this equation there are three parts. First part is 3a plus 1, and second part is 3b plus 3, and the third part is 3a plus 1. Now we take these first two parts, then we can write the relationship between a and b. So this implies 3a plus 1 is equal to 3b plus 3. 3a minus 3b is equal to, just we transpose the terms. Okay, this implies 3 of a minus b is equal to minus 2. This implies a minus b is equal to minus 2 by 3. This is a relationship between a and b. That's all. We have derived the relationship between a and b in the form of an equation. The difference of these two numbers, a and b, is minus 2 by 3, which is the required relation between A and B. Is it clear, my children? Whatever the data is given for us, it will help you a lot in solving the given problems. But first and foremost thing is, you have to read the question carefully. You have to understand the data, what is given for us and what is asked for us. If you understand the data clearly, automatically you will be succeeded 50%. in writing the solution of the given question, you will be succeeded 50%. The remaining 50% depends upon your memory capacity, which formula is applicable, which rule is applicable, which procedure is applicable. You have to recollect, you have to apply. Okay, my children. Now, take the screenshot of this page number 2. Take this screenshot of this page number 2. Make it fast. Take it fast.
Taken, sir.
Yes. Have you taken the screenshot? Now come to the question number 18. Question number 18. See the question number 18. For which value of lambda is the function defined by f of x is equal to lambda into x square minus 2x if x is less than or equal to 0, and f of x is equal to 4x plus 1 if x is greater than 0, continuous at x is equal to 0. What about continuity at x is equal to 1? So here we have to find the value of lambda. If it is a continuous function, at x is equal to 0. Given f of x is equal to lambda into x square minus 2x if x is less than or equal to 0, f of x is equal to 4x plus 1 if x is greater than 0, is continuous same procedure as we followed for question number 17. As we followed the steps to solve the question number 17, here also we follow the same steps. Here it is given that the given function is continuous function. In the previous question, in the question number 17, they asked you to find the relationship between A and B, whereas in this question, we had to find the value of lambda. Here only one variable, that is only lambda. In the previous question, they have given two variables, namely A and B. So we have derived the relationship between A and B. In this case, just we had to find the value of lambda, where if this function is continuous. At which point the function is defined here, tell me? In two ways. At which point this function is defined in two ways?
Sir, at 0, sir.
At 0. At number 0, see here. At 0. What is f of x here? Tell me. Left side. What is f of x? What is f of x? Left side. X is less than 0. What is f of x? Tell me. Tell me what is f of x? If x is less than 0, what is f of x?
So lambda into x square minus 2x.
Yes, lambda into x square minus 2x. If x is greater than 0, what is f of x?
4x plus 1, sir.
4x plus 1. Exactly at x is equal to 0. Exactly at x is equal to 0. What is f of x? So this is the given data for us. This is the given data for us. And also given that it is continuous. So let us find LHL, LHL and RHL. LHL. So let us find left hand limit as x to 0 minus limit f of x is equal to as x tends to 0. 0 minus means left side lambda into x square minus 2x. Since x is less than 0. Now substitution, direct substitution at x is equal to 0. So lambda into 0, finally we get 0. This is left hand limit of this function. Let us find right hand limit as x tends to 0 plus limit f of x is equal to as x tends to 0. If x is greater than 0, 4x plus 1. 4x plus 1. Because x is greater than 0. So 4 into 0 plus 1, that is equal to 1. F of 0, lambda into 0 square minus 2 into 0. So we got like this left hand limit, right hand limit and f of 0. Okay. We found left hand limit, right hand limit and f of 0. And it is given that if it is a continuous, if it is a continuous function, what is the value of lambda? Is it continuous? Just by seeing, just by observing left hand limit and right hand limit, can you say is it a continuous function?
Sir, it's not continuous, sir.
Actually, it is not continuous. Actually, it is not continuous. But it is given that it is continuous at x is equal to 0. Means for no value of lambda, for no value, if you take lambda value for any real number, it is not a continuous function. It is a continuous function for no value of lambda. It is a continuous. Means indirectly we say that it is not continuous. It is not continuous. We write that conclusion. Take the screenshot of this page number 3. First, take the screenshot of this page number 3. Fast.
Taken, sir.
Has taken?
Sir,
Have taken the screenshot?
sir,
Yes.
sir, I cannot see the below the screen, sir, like below lambda 0, sir.
Okay, it's okay, my dear Joseph.
Okay, sir.
Yes, I'm sending the screenshots. I'm taking the screenshots. I'm also taking the screenshot. Just safe point of view, I'm telling you. Okay. If you are not able to take the screenshots, ask your friends, ask your classmates. In case if there is any trouble, in posting the classwork notes by me in the classroom, if not, I am not able to post that classwork notes in the form of single PDF, then ask your friends to share that screenshots. In case, only in that case only. Only in that case. Okay. Not every time. Okay, my dear Joseph.
Okay, sir.
Even there is any problem, now I told many times, just for the name's sake, for the safe side point of view. So by observing these results here, actually left hand limit and right hand limit both are not the same. But it is given conversely. It is given that conversely it is continuous. It is a continuous function. Means for no value of lambda, it is continuous. We say that in the conversely, we give the statement conversely. Like this. For no value of lambda, f is continuous at x is equal to 0. No value of lambda, f is continuous at x is equal to 0. So we conclude that here. As x tends to 0 minus limit f of x is not equal to as x tends to 0 plus limit f of x. This implies actually as x tends to 0, limit f of x does not exist. Since these two limits are not equal, we say that its limit does not exist. So we conclude that for no value of lambda, we write reversely. For no value of lambda, it is continuous. It is continuous for no value of lambda. So if you take any lambda value, it is discontinuous only. If you take any value of lambda, any real number for lambda, it is discontinuous. Indirectly, the meaning of this sentence is it is discontinuous for any value of lambda. Okay, so for no value of lambda, f is continuous at x is equal to 0. It means for any value of lambda, it is a discontinuous. If you take any real number, just for namesake, you can take lambda is equal to 1, lambda is equal to 2. You can verify it. If you take any real number for lambda and if you check that continuity, it is a discontinuous. That is, I will write that sentence also. That is, f is discontinuous discontinuous at x is equal to 0. At x is equal to 0. Okay, my children, this is the first part of this question. And there is a second part. What is the value of lambda if it is continuous? The second part of this question is if f is a continuous function, in that case, what is the value of lambda? That is the second part. So, that is part 2. Finding value of lambda, if f is continuous at x is equal to, if x is continuous at x is equal to 1, it is given, see here, the question itself, if what about continuity at x is equal to 1? What about continuity of f at x is equal to 1? So, let us verify. Here also left hand limit. Exactly at x is equal to 0, it is defined like this only. Here f of x, lambda into x square minus 2x, f of x is equal to 4x plus 1. F of x is defined as lambda into x square minus 2x. Like this it is defined. Okay. Then what about at x is equal to 1? See here at x is equal to 1, whether it is defined left side and right side. Is it defined left side and right side? Is it defined left side and right side at this particular point 1? Is it defined f of x at this particular point 1, left side of 1 and right side of 1, x less than 1, x greater than 1, like this? Is it defined?
No, sir.
Not defined left side and right side of this number 1. So we find directly, limit directly, because at this particular point 1, f is not defined left side of 1 and right side of 1, less than 1, x greater than 1, like this it is not defined. So as x tends to 1, limit f of x, find it directly, we find 4 into x plus 1, sorry 4x plus 1, because x is greater than 0. Here x is greater than 0, so this we have to take this function only. So 4 into 1 plus 1, that is 5. Now f of x, so f of 1. F of 1 is this function only, at x is equal to 1, at x is equal to this only. So 4 into 1 plus 1, because x greater than 0. So here we got 5. Both values are equal. Both values are equal. So it is a continuous function. It is a continuous function or not? Is it
Continuous, sir.
So therefore, as x tends to 1, limit f of x is equal to f of 1. So f is continuous at x is equal to 1 for every value of lambda. For every value of lambda, is it affected by the value of lambda? Is still these two results affected by lambda?
No,
Not
sir.
at all. Not at all. So for every value of lambda, for every value of lambda, f is continuous at x is equal to 1. For every value of lambda, in the previous case, for no value of lambda, it is continuous. But here, for every value of lambda, if you take lambda value, any real number for lambda, it is continuous at x is equal to 1. At this particular point, it is continuous. Okay, my children. Now take a screenshot of this page number 4. Take the screenshot of this page number 4. Take this fast. Take this screenshot fast.
Taken, sir.
Have you taken?
Yes, sir.
Only for safe side point of view, I am telling you. Now see the question number 19. Show that the function defined by g of x is equal to x minus step x. X minus step x is discontinuous at all integral parts. At all integral parts. Here, step x, that is read as step x. Square brackets, within the square brackets, x is given, it is read as step x. Greatest integer function. You have learned greatest integer function, that is also called step x. In your earlier class, in 11th class, some real functions. You can go through the definition of step function. In the functions chapter, in 11th class, you can go through the definition of step function. It is also called greatest integer function. If you learn, if you understand the definition of greatest integer function, you can solve this question easily. See here, it is step x denotes the greatest integer function less than or equal to x. We have to show that it is a discontinuous x minus step x. X minus step x is discontinuous at all integral points. Integral points means at integers. Can you tell me what are integers? Can you tell me what are integers? Can you tell me what are integers? Don't you know integers?
Sir, values from minus infinity to infinity, sir.
Tell me the integers clearly, not minus infinity to minus infinity. 1.5, is it integer? 3.5, 3.2, is it an integer? You told me minus infinity to infinity.
Sir, all whole numbers, positive and negative.
Only whole numbers are integers?
No, sir.
Only whole numbers? What are integers? These numbers, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. These numbers are said to be integers. Not all the numbers between minus infinity to infinity are said to be integers. Only these numbers, minus and so on. Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on. These are only said to be integers. These are said to be whole numbers. What you said, Yashwant Ram, these are said to be whole numbers. You have not included negative integers.
Sir, I said positive and negative, sir.
You said only non-negative integers. You said only non-negative integers, means whole numbers. You said
Sir, I said
only
positive and negative.
positive integers and negative integers and including 0.
Yes.
Okay. These are only said to be integers. At these numbers, at these integers, we have to show that the given function is discontinuous. Okay, my children? Yes. Now the time is 11 past 46 minutes. Now you can leave the meeting. We will discuss this question in the next class. In the meantime, please read that definition, greatest integer function definition in the first year functions chapter. I am telling you clearly, no need to search for the definition, the entire textbook. No need to search for this entire textbook of first year maths textbook. Only open the functions chapter in first year textbook and see there. In the textbook, it is the greatest integer function definition. Go through that definition well, understand that definition well, or go through the classwork notes which I gave, the definition notes for that greatest integer function. Okay, medicine, be ready with that definition. Now you can leave the meeting.
Thank you, sir.
Take rest, take care of your health.
Thank you.
Stay at home.
Thank you,
Thank you,
sir.
sir.
Sanitize your hands frequently and maintain social distance of 2 meters away from others. And thank you all, my dear children.
Thank you, sir.
Thank you all. Thank you, my dear Joseph. Thank you.